Hello and welcome, and in this video we are going to be talking about factoring quadratic trinomials. Now, I cannot express enough how important this particular topic is because we use it so frequently throughout Algebra 1, Algebra 2, Precalculus. It even makes its way into calculus, so very, very important topic. So before I get into factoring a quadratic trinomial, we have to first kind of work our way backwards. So I'm going to introduce it once again with a multiplication problem, because remember, factoring is just undoing multiplication. So if I was multiplying these two, right, I would distribute the 2x to the x and the negative 4 to get 2x squared minus 8x, and I would distribute the 3 to the x and the negative 4 to get 3x minus 12, and then that would end up combining like terms to get 2x squared minus 5x minus 12. Now, the only thing is, a lot of the times we're going to actually want to work our way backwards. We're going to be given the 2x squared minus 5x minus 12, and we're going to want to work our way backwards to these two factors, 2x plus 3 and x minus 4, because we use this to solve so many different types of equations. Now, before we talk about that, I need to talk about the standard form of a quadratic expression, which is ax squared plus bx plus c, where a, b, and c are just numbers, okay? So a, b, and c are just numbers. So in this particular problem, a is 2, b is negative 5, and c is negative 12. And the reason I bring that up is because we factor these trinomials utilizing all of these values in a special way. Now, the first thing that we do when we are factoring a quadratic trinomial is we bring down the first term and we bring down the last term. So I'm bringing down 2x squared and I'm bringing down negative 12. And now what we're going to have to do is we're going to have to split up this middle term. I need to split up negative 5. And the way we do that is actually kind of special. We have to find two numbers that multiply to a times c and add to our middle term of b. And that sounds very complicated, but that's actually not that bad. So I need to find a pair of numbers that multiply, in this case, a negative 24, and add to negative 5. So I'm multiplying 2 and negative 12 to get that negative 24, and now I have to choose a pair. Now, since we're multiplying a negative 24, one of the numbers in each of these pairs is going to have to be negative. Some of you might be able to quickly realize what those numbers are. If not, just make a little table like this. You will get more comfortable with it as we go on, okay? So just looking at this, I know for a fact there's no way it's going to be 1 and 24. 1 times negative 24 would get me negative 24, but it's not adding to negative 5, and the other way around is not going to work either. Neither is 2 and 12, and neither is 4 and 6. What does end up working is 3 and 8. Now, if 3 was negative, that would multiply negative 3 times 8 gets me negative 24, but it would add to a positive 5, or I want to add to a negative 5. So if I put the negative on 8, 3 times negative 8 does get me negative 24, and 3 plus negative 8 does end up getting me negative 5. So those are our two numbers. Those are the numbers we are going to plug in. So we are going to split up the negative 5x and make it negative 8x and positive 3x. Notice I didn't change the problem really at all. If I did negative 8x plus 3x, I'm right back at negative 5x. So I didn't actually alter the problem. I just expanded the negative 5x. And these numbers should look familiar because they're exactly what we got over here. When we multiplied these out, we ended up with negative 8x and a positive 3x. And that should make sense because remember, factoring is undoing multiplication. So what I'm doing is I'm basically undoing that distribution, okay? So those numbers should look familiar and they should make sense. Now from here, we are going to do something called factor by grouping, where I group my first two terms and I group my last two terms, and I take the greatest common factor out of each group. So if I look at my first group, I have 2x squared and negative 8x. The greatest common factor there would be 2x, so I would factor out a 2x to get 2x times x minus 4. Then I would look at my second group, which is 3x and negative 12, and my greatest common factor between those two would be a positive 3. So I would factor out a 3 to get 3 times x minus 4. And this is where something special happens. What we should recognize is that there is a common factor of x minus 4. Each of these have an x minus 4. Now this needs to happen. If this does not happen, you need to take a look back at your work. Did you grab the two numbers correctly? Did you incorrectly factor out the greatest common factor? Just check your work, because this needs to happen. Because since they both have a common factor of x minus 4, I can actually factor out an x minus 4. And what's going to be left over is the numbers out in front, the 2x and the positive 3. So that would end up actually making my second binomial. And as you should see, this is exactly what we should have ended up with. As we see, we have x minus 4 and 2x plus 3, which is exactly what this originally was. So this is how we undo this multiplication. This is how we factor a quadratic trinomial. Now, this does require a lot of practice. So I am going to go over another problem or two, and I'll probably make another video or two of just these particular types of problems. So let's take a look at another example. All right, so let's take a look at this example. So we have 3x squared plus 8x plus 4. And I want to factor this quadratic trinomial down to its two binomial factors. So the way I would do this is I would once again need to find the two numbers that multiply to a times c and add to b. Well, a times c in this case, well, that would be 3 times 4, going to end up being 12. So I need to find the pair of numbers that multiply to positive 12 and also add to 8. So you might be able to recognize what that is right away. If not, you can make a kind of list. So I can do 1 and 12, I can do 2 and 6, and I can do 3 and 4. These are the only ways I can multiply to 12. Now I need to pick the pair that multiply to 12, but also add to our middle term of 8. And those numbers would be 2 and 6. 2 times 6 gets us 12, and 2 plus 6 gets us 8. So I bring down my first term, so I'm bringing down at 3x squared. I'm bringing down my last term, which is 4, and I am splitting up my middle term. I'm splitting up my middle term using these two numbers. So a positive 2x and a positive 6x. And it does not matter in what order these two go. You can place a 6x here and a 2x here. It does not matter. Okay, so I go ahead and I break up the middle term using these two numbers. And now what I do is I factor by a grouping. So I'm going to group the first two terms, 3x squared and 2x. I'm going to group the last two terms, 6x and 4. And now I'm going to take out the greatest common factor in each. Now in this first group, 3x squared and 2x, the greatest common factor is x. So I would factor out an x to get x times 3x plus 2. And in the second group, the greatest common factor between 6x and 4 would end up being 2. So I'd factor out a 2, and when I factor out a 2, 6x divided by 2 is 3x, 4 divided by 2 is 2. All right, so I have x times a quantity of 3x plus 2 plus 2 times a quantity of 3x plus 2. And remember, this needs to happen. I have that common factor of 3x plus 2. I have this common factor of 3x plus 2, and this needs to happen. If it doesn't, take a look back at your work. But it does happen, so I can factor that out. So that's going to be 3x plus 2, and the other binomial is going to be made up of the leftovers, x plus 2. And this would end up being our final answer. One of our factors is 3x plus 2. The other factor is x plus 2. You can verify this by multiplying this out. If you were to multiply this out, you would end up right back here. So remember, that is a way you can always double check your answer. Let's go over one more example, and then we'll call it a day. Let's do something like this. So we have x squared minus 14x plus 40. So remember, we are going to have to break this down. But first, I'm going to bring down my first term. I'm going to need to split up my middle term. I'm going to bring down my last term. Let me go ahead and actually write that a little bit neater, maybe space it out a little bit, plus 40. All right, now I need to figure out how to split up that middle term. And remember, that is when we do a times c. So in this problem, a is just a number 1, so it's going to be 1 times 40. So that multiplies to 40, right? So I need to find a pair that not only multiplies to 40, but adds to negative 14. Well, I can do like 1 times 40. I can do 2 times 20. I can do 4 times 10. And I can do 5 times 8. That's our only 4 pairs, okay? Now, the only thing is, I do need to multiply to a positive number, but I do need to add to a negative number. As is, none of these are going to work. However, if I change both numbers to negatives in each pair, that's still going to end up multiplying to a positive 40, but now I can actually add to a negative number. So negative 1 times negative 40 does multiply to 40, but it does not add to negative 14. Neither does 2 and negative 20, and neither does negative 5 and negative 8. However, negative 4 times negative 10 gets me positive 40, and negative 4 plus negative 10 gets me negative 14. So this is our pair, negative 4x and negative 10x. So these would be our two numbers. And now I can factor by grouping. So I'm going to group the first two terms. I'm going to group the last two terms. Now in the first group, the greatest common factor between x squared and negative 4x is just x. So all I can factor out is an x there. And that's going to leave me with x times x minus 4. Now in the second group, the first number is negative. This is one thing I want to bring up. Whenever the first number is negative in one of those groups, we are going to want to factor out a negative number, okay? So now I'm looking at 10 and 40. The greatest common factor there is 10, but instead of factoring out a positive 10, I'm factoring out a negative 10. And the reason is now, when I factor out a negative 10, well, negative 10 divided by negative 10 is 1, so that'll just be 1x, and 40 divided by negative 10 is negative 4. Now these two binomials match up. If I didn't factor out a negative 10, this would become negative x plus 4, and they would not match up. So when the first number in a group is negative, factor out a negative. Because now I have that common binomial, I have this common factor of x minus 4. So I can factor out and x minus 4. And my other binomial would be made up of these leftovers out in front, x minus 10. And this would end up being our final answer. And once again, you can double check this by multiplying this out. It would end up giving us our original answer. So that is factoring quadratic trinomials. I will make another video with a couple more examples just because practice makes perfect, and this is such an important topic. I really hope this helped. If there's any questions, please feel free to let me know, and I look forward to seeing you guys in the next couple of videos.